All right, good morning, everyone, at least over in Australia, and whatever relevant time zone greeting for you if you're not in Australia. It's a pleasure to be the final talk wrapping up Solution 2. There's been quite a few interesting talks that I've watched along throughout the week. It's been quite a good couple of weeks with .NET Conf and Solution 2. So I'm excited to be talking about building a fun little game with Blazor on .NET 9 because that's, well, the latest thing out. So without further ado, let me jump into it. So what are we going to talk about? Well, first we'll just explore what can you actually do, what's the possibilities with Blazor versus desktop or just plain JavaScript. Then we'll talk about some very, very brief game design, just enough to be able to build this game. Okay, and then we'll finally build it, so that'll be 90% of the talk. Then finally we can play together, so there'll be a QR code and we can play what we just built, and hopefully that will spark some inspiration for everyone. And then finally I'll just conclude with links and everything useful there. So who am I? My name's Luke Parker, a full-stack engineer. I've been personally building with Blazor for about 6 years. I looked at some old projects and the first commits start around there. Commercially in production for about 3 years across a couple of different companies. And the other qualification for this talk is that I've been playing games for way too long, or not long enough, depending on how you look at it. You can find me on GitHub as Hona, which is my same name on Discord, and then I blog at lukeparker.dev. So to set a premise for this talk, it really is just a way to reframe skills you already know, maybe building enterprise software, and just let you think about it in a fun way. So I like this quote from Albert Einstein: the measure of intelligence is the ability to change. So what we're going to change is, hey, those skills you already have building enterprise software, it's not that much of a gap to be able to express yourself creatively, potentially building a game or other sorts of fun apps. So let's jump into it. What can we actually build with Blazor? So first we have to talk what is Blazor, very briefly. So we write web apps with Blazor through a component-based model. Okay, we can write it with C#, HTML, and Razor markup. That's what Blazor combines. We can render with several different modes, especially since .NET 8. Okay, you can have completely static server-side rendering. You can have interactive server-side rendering with a SignalR connection that lets you have real-time updates computed on the server. You can have client-side rendering, so that's what we're going to use in this talk, or the new interactive order, which is a combination of both. Okay, there's a few games on the web that I like to talk about just to show the different types of games you can make. We can make games that are text games on the web. Okay, Blazor can do that completely fine, right? You're just displaying HTML, you're updating the DOM, you're taking an input. That's completely standard. That's one fun type of game. There's another one where you try to draw graphics on the web using the actual DOM. So instead of drawing like you would traditionally on the desktop, well, you might try styling with CSS, modifying classes on some JavaScript thread, and displaying it with CSS. Now this one's an interesting one. There's a collection of Blazor games on this link, which I've linked at the end as well, but it's quite a cool resource. The other type is Flash games, or, cool maths games. A lot of people might know this if they're around a similar age as me, but, the web can run that, although it obviously might be a little bit outdated these days. The natural kind of successor to the Flash games in the very similar vein is those 3D rendering tools you can have. So there's 3JS, but there's even WebGL and a lot of those technologies which let you actually treat what you're coding very similar to what you're doing on desktop, where you're actually doing pixels, and it's pretty strong. But for this talk, sorry, there's one more actually. I've got to mention Cookie Clicker. It's an incremental game, so it's really based on a number, and then you click a bunch, and then a number goes up, and then the screen gets more and more crazy the bigger the number gets. I've spent some time playing games like this. So what do we want to build? Well, I want to build something similar to that incremental game, just because it's fairly simple and it will show some of the strengths of Blazor, I think. And it's also simple enough to build in this talk. So I'll expand a little bit on that when we're actually coding it. But let's talk about the game design a little bit. So how do incremental games work? Well, it's a very simple premise. Essentially, imagine this graph where the bottom axis is the level, so you want to level something up, and then on the y-axis, let's imagine it's the amount of times you have to click to get to the next level, or the amount of experience, quote unquote, whatever that means, to get to the next level. And really, this curve, the exponential curve, or whatever other type of curve you might use, is used to hook you in early where it's moving really quick, but then it starts to taper off where the next levels get harder and harder. So you kind of get hooked early, and then as the challenge increases, that's quite addicting. Now what does this look like in code? Well, you can build a simple curve like this by saying, hey, the amount of experience or clicks or whatever that you want to define that y-axis as is equal to, in brackets, the level plus some sort of offset if you want to increase that first level, raised to the growth rate, so how fast you want this exponential curve to grow. So that really is going to be the premise of a lot of the game we're about to build. What is the gameplay loop, though? So how are we going to make it work? Well, like I kind of mentioned, you click, or you wait, or you do both, depending on how fast you want the third to happen, which is the numbers going up, right? So the fastest way to make the number go up is to do 1 and 2 as much as you can. So that's really going to be the whole gameplay loop. And it makes quite a fun game with a lot of web tricks and just, putting creative things in your website. So that's all of the introductory slides. The rest of the talk, other than the closeout, will be coding. So let's jump into it. I've already spun up a empty .NET project, just so I don't have to open the terminal and have it crash for whatever reason. So let's pull it up. All right, so I've got my Blazor app here. It's a empty WebAssembly project, although it is in the new 2 project model. You could do it in one project, but let's just pretend I'm thinking potentially I'll have authentication later, and I want that to be completely server-side rendered. So let's just leave it as is, although it's not too important. What do you get out of the gate with a empty client-side Blazor app? Well, let's hit run, and hey, that's pretty sweet. We get some text, we get a hello world, and then we get Chrome updates as it happens, I guess. Okay, so how do we build a button, this incremental game where I click and wait and a number goes up? Well, let's build a very simple example of this before we go and make it too crazy. So on the home here, this is the text we just saw. So let's just start by adding a button, right? And let's say it's just called click me, right? And what do we want it to do? Well, on click, we want it to increment some sort of number. So let's say all it does is, it is a function that increments a number. So let's say it's just money or something. And we can say, hey, money goes up, which that's always good. Now we want to make a variable for the money, so let's say you start with $0 and then you click. Okay, well, what happens when we restart this? We'll let it build really quick. And we pop up here. Now we can click the button, but I did forget to put in a display of your money, so let's actually put in that first. Okay. Now, let us wait again. And up here, when you click the button, oh no, the number doesn't go up. Well, what's going on here? So if you've touched Blazor a few years ago, it would work as you expect, but since .NET 8, especially in this model, by default everything is server-side rendered, static as well, if you haven't set global interactivity, which we haven't. So what I have to do in this case is say the render mode is interactive WebAssembly to specify in this case that I want it to run on the client and be interactive. So let's try one more time. Okay, hitting run. And now when I click, it in fact still doesn't work. And we're getting compile errors. Not bad. I'm going to open up the terminal and do a clean build. All right. Now, I've just realized from my sample app, it's not best to put your client-side components in the server project. It's a weird thing to explain, but essentially you have two runtimes somewhat. The .NET, the way the new Blazor web app works is very weird, and I've noticed the Microsoft people talk about it, but it's very funky in how they explain it. Now what we can do is instead just place our routable page instead on the client here. So what I'm actually going to do, because this is the quote-unquote server project, and the client project here is for everything on the client side. If we just rip out this home page and move it to the client project, right, we can look and see in the routes that this new Blazor web app looks at two projects for its routable pages. So we have the program assembly, so this server piece, and then it also loads routable pages from the client imports over here. Okay, so let's try one more time. I'm going to, again, just stick with the terminal. Here we go. Noticing I love the new interactive style for the SDK. So if we click here, woohoo, we get the numbers going up. So this is one tip I want to give people. I kind of intentionally leave this weird issues where, first of all, it's static and in the wrong side, because these are the exact gotchas that people will hit into and not find the fix for and maybe toss Blazor away. So we could probably improve training and resources out there, but I like to go through these mistakes just to show people, like, yes, it's very scary, but it's very easily to fix as well. So the main takeaways is, by default, all of your pages are static server rendered unless you've specified global interactivity. In the new paradigm, the .client you can think of as a separate app, but you want all your client-side projects to be here, pages and components. And then server only you want to leave in here. There's in the main project. Now there are some weird caveats, like where do you put layout that's used in both, but I'm not going to dive into that so much today. So let's jump back in right to our game. We have a button. Now I could just spend the remaining hour here clicking this number a bunch, but I'll get bored of that gameplay loop a little bit. Now just a tip as well, if you're building clicker games, a trick, sorry. If you hold down Enter, you can save your fingers carpal tunnel, hopefully. Now, a lot of games disable this, but as the developer, I'm going to leave it in at least in dev time, right? So holding down Enter on a button helps. Now, that being said, I want to build out the basis of a game. So we want some upgrades, like I mentioned, that whole curve. So we want to increase the money a bunch, but it's got to cost money, so you got to spend money to make money. So what I'm going to do is I'm going to jump into this layout, and then in the layout, I'm going to say, I'm going to pretend like I know modern HTML. So let's say we have a header, okay? And I want to display how much money we have. So I'll make a new component called the currency balance. So like I mentioned, Blazor is very component heavy. So we want to think in that paradigm. Now, there are performance concerns to using a heap of components. However, I mean, we're not doing any large computations, so it's not a big worry here. Now, in the main part of the app, we will put in the body, which is the routed component, right? So whatever's under a page gets rendered inside of the layout. So we might want to have separate pages in the future where maybe there's different zones in the game, but for now, let's just stick with this. Okay. Now, in the UI, in the client project, let's structure some of these components a little bit. So let's pretend it's a little bit gamey, right? So there's some scenes. In the scene, there's, let's say, the shop first, because, you know, we mentioned that, right? So let's say there's the upgrade shop, and let's say there's a currency display for, you know, how much money you have. Okay. Now, in these components, how do we share data, right? When I have this money variable, I could use the traditional way, which would have two-way binding between a bunch of numbers. But what if that increases and there's more variables and whatnot? So, okay, maybe we don't want to be using parameters and passing a lot of that there, at least for this demo, to keep it quick. So in this case, let's go and build the actual grunt of the logic. So it's somewhat separate to Blazor. We can essentially just build, you know, pure .NET classes and then use that later. So I'll talk about that in 1 second. But let's say I want to build something to track what upgrades we have. So we'll call it upgrade.cs as that loads. Now, let's say there's a few different types of upgrades. Okay. We'll have a sword, say, that increases damage we do. Okay, let's say there's a laser that does passive damage, so we can wait and not have to click. Let's say there's poison that does, you know, makes your click do some percentage of what your passive damage is, and then increases the amount of passive damage. So we'll do this by making the passive damage happen more. Now, obviously, you can do whatever you like with your game. I'm just using a few samples in this case to kind of show the power of it. The next thing is, let's build a record that tracks what level your upgrade is, right? So let's say it's the upgrade state. Okay. In here, let's say, oops, let's not type in the namespace. Let's say there's a level. Right, what level is this upgrade currently at? Let's say it's got a base cost, a growth factor. Let's say we can seed a new one, starting at level 0. The current cost is a formula, right? The base cost times by, and then this is that exponential curve. And then we are basically overriding the level from the primary constructor so that it is settable. Now, this is just a fun little record thing, so we don't have to use all properties, but be able to mutate at least one. Okay, the next thing is we want the whole game state. So let's go game state up here. Okay, and then in the game state, I want to track a couple numbers. So first, I want to have the currency as a double in this case, just so it's fast. You probably want to use a decimal if you want precision, but you know, I just care about performance in this case, and don't really care if someone gets the incorrect amount of money. Now, if you see the word double next to currency in the real world, you should probably cry and fix that as quick as you can, because that is really, really not good. Okay. So let's also track the amount of enemies that we defeat. So what I'm going to do is, in the game, instead of just clicking the button and the money goes up, we'll add another interaction, which is you click to do damage, and then every time you defeat an enemy, the enemy resets, but you get money for that, right? So the amount of money, how many we've defeated. Let's track how many clicks it takes to defeat the enemy, right? So in this case, let's say it takes 10 clicks, and then when you click 10 times, you get the money. All right. Let's then say how much is their current starting health. So an exponential curve. This is the offset that we mentioned essentially, you know, with an exponential curve up there based on how many enemies you've defeated. Okay. The next thing is, what is the current enemy health? So we want to track, if I've clicked it 5 times, well, I'll need some number there to track that this enemy's at 5 health out of maximum 10, as an example. Now, we will build out some extra pieces here. So I first want to track the upgrades that we have. So I'm going to paste in this snippet. AI probably knows it fairly well. But here, let me talk about it. I'll close this just so we can see for now. We've got a list of upgrades that we can get. We'll use this basically dictionary to display in the Razor component what upgrades and their state. You know, it's somewhat ordered. Now, this isn't an order dictionary, so it doesn't really matter. But let's say for those 4 upgrades we created, we'll seed them with different costs, maybe increased growth factors using those records. You know, just defining some basic curves. So, you know, you initially might want to upgrade the sword, and then once you can earn more in-game money, then maybe you'll upgrade these harder to get upgrades. Okay. So we did put comments in the upgrade what they do. 2 of them are active, and then 2 of them are passive. So if I jump back, I'll leave this closed for now, actually. The passive damage is that just the level. So you do, if it's level 1, it'll do 1 damage every, say, second, right? Now I'll talk about the rest of it shortly. Now, we want to add some functions to be able to do things. So let's cause some damage, okay, by passing in the passive damage. So whenever we want to tick the passive damage, then we'll call this method that we're about to create, okay? We also want to be able to do click damage. So here we can say you start out by doing 1 damage every click, and then there's a few different stacking upgrades, right? The actual damage we want to do is your base damage, plus, for now we're just saying every level does, you know, 1 damage, right? We're saying 1 plus, and then the level plus, and then there's this extra upgrade which applies that 10% of your passive damage based on the level, so it stacks, right? And then we damage the enemy with whatever that number is, right? So you can add in formulas, you can stack a whole bunch of upgrades and, you know, figure out whatever interaction you want in that case. But you can have some fun with that. Now, to damage the enemy, it's fairly simple, right? We want to deduct damage from that enemy health, the current health. If their health is less than 0, then we want to defeat them and then give the player $1 or currency, right? Now, currency will add in the amount, right? That's it. That number will just increase it. The other thing, though, is when these numbers change. So for now, we want to actually trigger an event when important things occur. So up the top, I'll actually just paste in this. So we'll have an action with no arguments, so we don't care about passing any data. And all we'll do is use this as a way to notify components that they should just re-render and use the latest numbers. Now, there are better event patterns or reactive patterns, but for this is just using very basic you know, tools to show a point, right? So, okay, when we add currency, we definitely want to show the player that they have more money because they want to see that immediately. So, like I said, I added the event. So let's instead add in a way to invoke that state change, right? And then in here, we will on state change, invoke it, and there's no arguments or anything. Okay, when we add currency, let's invoke that state change. Okay. Now, when we defeat the enemy, when we damage them, sorry, it won't re-render and show the current health. So we also want to invoke the state change here, and then only invoke the state change if their money increases as well. This could cause a double render in this case, but we shouldn't have too many re-renders. So for now, for the sake of the demo, let's keep it slightly inefficient just to move fairly quickly. Okay, the next thing we want to implement is this missing method, right? How do we say an enemy is defeated? Well, we'll just increase the count of enemies that were defeated, and then set the current health to the next level. So remember, the next level health depends on the number of enemies defeated. So when we use this down below, we can just fetch that number and it's automatically calculated. Okay. Now, the next thing, the final thing we want for our game state, right? We're just building pure .NET in this case. We can kind of think of your app, which is also a good way to think of Blazor apps. You can get into a lot of issues if you don't do this. It's good to think of build your logic separate to your components, keep your components as simple as you can manage, and then your component should interface with some logic elsewhere. Okay? Now, let's finish up. So the last thing is we want to be able to purchase an upgrade. So we can grab the current state of whatever upgrade enum we've specified here. If you have enough money, then deduct the money, and then increase the level, and then notify the UI that something changed. Now, we might want to lock things later on, but if someone figures out a way to invoke this, that and break it, then they deserve the free money, in my opinion. Okay, so we've built the crux of the UI here. Let's just build the currency display first. So how do I get this game state in to my components, right? So over in the program.cs in this client project, right? It's kind of like two runtimes, as I mentioned. I want to inject a singleton, and that singleton is going to be the game state, right? We've added a class. We want there to be one instance that's shared. Now, because it's client-side, a singleton really just means there's one per client, right? It's not shared among all your users, but that could be a quite interesting gameplay mechanic if it was server-side, potentially, right? The next thing is, for now, we haven't disabled pre-rendering, which is another gotcha, which I won't show the mistake of, but we do actually want to add this server-side for now because the app will first pre-render it. So we want it to be accessible for now. I could just disable pre-rendering, but I'll add it in both cases. Okay. Now, in the scene, we want to first inject this game state, right? Then we can say it's we can, for safety, let's just say it is interactive, just to be really specific. Then we can display this number. Okay. Now I didn't type out the parameter name. Okay. And then in the code, well, we want to display, for now, let me actually just cut out this animation, right? I just want to show we've got an injected game state, and then we're formatting that number somehow, and it's available. But there's that event we have to register to. So on initialized, we can wire up to game state, game state, and we can say that on that state change, we'll handle this, and all it will do is in the background, so we're not going to await this, it'll say, hey, state has changed. Okay. Now, because this is an event, we also have to say that it implements iDisposable, because we just wired up an event handler here. So let's say public void dispose, and then unregister from that. Okay. But this is going to get quite painful doing this for every single component. So what we can do is we can actually implement a common component, right? And then we'll make what's called a game state component base. So game state component. Now what this can be is, again, just pure a C# file. It doesn't actually have any rendering code. All this is going to be is an abstract base class that inherits component base. So this is what every Blazor component is inheriting from. But it's going to be what we just built as boilerplate to get wired up to the game state. So it is going to be iDisposable. We're going to inject in the game state. Okay. And then we'll just run for them on initialized, wire it up, dispose, tear it down. Okay. So we have a base class here now. On that currency display, instead of having to inject this, having to say it implements it, wiring up these patterns here, we already have status changed here. Let's, that's fine actually for now. Let's just leave it as that. We can now just basically tear it all away, right? And all we can do now is we can say it inherits from, and then say the game state component, right? Might be a good idea to add some of these things to the global usings. So let's add an import for the common folder, because everything will be using this component, right? In this case, it simplifies the code quite a bit. All we say is this definitely wants to be interactive. You're a game state component, and then now we have access to this variable, right, where we can use the currency. Okay. Now, I'm going to add in some styling, but I'm not going to style live because CSS is definitely not my strong suit, but I've pre-cooked some stuff that looks a little bit like the slides, if you recall this. Okay. I'm going to override the default app with just 100 or so lines of CSS, maybe 200 lines of CSS. And all it is just some colors and animations and, layout. Now, if you want to learn about CSS, right, there's lots of resources out there. The other thing is, we mentioned we have an enemy, so I want to paste in just an image that we can use as that enemy, okay? So we have currency, and then we'll display some upgrades shortly, but we haven't built basic scenes for where that enemy would be, on the page. So instead of having this home.razor, that just proved the point, basically. I'm going to toss that away. And let's build, instead of the shop, let's build out a battle scene, right? Now, a naming pattern I like in Blazor projects is any routable page I like to suffix with the word page. So I'll just call this battle page to denote that it is routable and kind of the entry point. So it's going to be a page on the index there. We're going to say it is definitely interactive on the client. Okay. Now, we added that nice base class, so let's also say it inherits from the game state component. Cool. Now, we mentioned and built in the game state, right? There's a progress bar, realistically, of how much the health is, and we'd expect each time you click, it goes down. So let's do that, right? Let's say there is a progress bar, okay? Let's then say it has an ID. We'll use this later. Enemy progress ID. We'll use that as a variable shortly. Let's say the max number for this progress bar, we can fetch from the game state and say, well, the current max enemy health is that maximum number, right? HTML will do all of the heavy lifting for us here. And then let's say the enemy health, that's the current number there. Okay, that realistically is a progress bar that will update, and with the CSS we paste it in, it'll animate a little bit and be colored. Okay, now we also maybe just want to show what the number is, because what if that number gets really big? I want to see it's 80 out of 100 for just some specificity on it. So let's say the label is for this ID. Okay, now we can reuse this parameter or variable, right? And then let's display something. So, well, the realistic health is those same variables we used. So the current health, and then we'll just say, so we're not actually running math here. It's, if we wanted to run math, we'd need parentheses, but we do want to display the slash. So enemy health, and then it's out of, again, that same maximum. So the game state dot current max enemy health. And we'll hit tab on that. Now let's just define this little string that we reused and just say, hey, it's enemy health. Okay. Now people are very visual, especially in games. So let's go down here and let's put an enemy image. We'll define that. We'll just basically link to this SVG in another component. Okay. Now, the last thing is that button we built in the homepage before. What we want is almost the same code, right? We have a button. When you click it, do something. But in this case, we want to invoke this click damage that we built in the game state, right? So we kept our logic somewhat separate. And instead of clicking and doing math in here, we just invoke a method that's controlled elsewhere. Now, the last thing we want is, let's just add in this image, right? So let's say in the component we have an enemy image, and all we're going to do in this is wire up the SVG. Now, if I paste this in, it has that exact path, so ww root on the server, that will be served here. We've added some alt text. He looks like a little ghost. You know, if you disagree, you know, you can name its alt text whatever you like there. And then we've given it a little bit of size and then a class. Okay. Now, this is probably going to be in a mostly broken state, but I would expect when I click, these numbers update, and then this separate component, right? We've got a battle page. We also have this currency, right, in a separate component. It should look like that number updates because of our magic component. So I'm going to attempt to build it and see what happens. So let's .NET run again. I love watching the number change. It's been so long using the old .NET 8 and below SDKs. So when I click this one, I have something. Now, it looks a little bit different because we added in styling. Okay. I'm noticing I think the currency display is missing. But when I click this button, at least, it animates and colors overwhelm you, so you know, are visually just, you're seeing things. But hey, this number changes, the progress bar updates, that image that we put, so the home page right here, right, is all there. Now, looks like the currency display didn't wire up, so let's at least prove that works. So we need to fix it. It looks like it would be a missing using statement. If anything, there probably is some warnings here in the build that would help us. One of them, look at this, found a unexpected component, currency balance and upgrade shop. Add a using statement if you forgot it. So one thing you could do is mark these as warnings as errors. It's probably a really good move in a production app because it's very easy to refactor and accidentally have the wrong namespace, and some components silently don't work anymore just because they're not found. But in this case, I'm just going to fix it by adding in the using. So in the main layout here, let's just say, even in this component, we could even put in the imports. If I put in the shop, and then we don't need the common, but we want the battle scene potentially, even though that's routable. Okay, now the currency balance is still not displayed. Let's check what namespace that is. That is in, so the client, scenes, and then shop. And then if we check this, client, scenes, shop. Now it does look like the ID is probably lying to me in this case, so I'm just going to rebuild and see what happens. So let's open it up one more time. Now, it looks like it's still broken. Let us just explicitly give it the namespace. I'm not sure what's going on there, because it does look... Oh, it's currently balanced when the component is called currency display. So that is also an easy mistake to make. There we go. So the ID wasn't lying to me. I almost slandered my favorite ID for no reason. So let's run it one last time. I'll instead use .NET Watch so we can just keep those live reloads happening. So that's spun up. So when I pull this down here now, we see this big number, and when I click, nothing happens, and then the number goes up, but I'm kind of staring in this region, and when the number goes up, I don't really notice it because I'm just really focused on clicking this button as quick as I can, right? Okay, maybe we want it so that, you know, you see the number and you think about it a little bit harder. Now when I hold down enter, you'll see that that number started out as 10 max health, but it slowly gets harder and harder to defeat each enemy, right? It's going from 10 to 11 to 12 to 13, and it will slowly scale up. Now, we're kind of rich here, we have $41, woohoo! Except, I'm not really seeing that number, so let's make that number do some cool stuff. What we want it to do is, when that number goes up, we want it to kind of wobble and go, hey, you want money, you should look at me. So, I did rip out that code, right, in this currency display. But what we want is, we'll say, when you're animating, so we'll create this animating variable shortly, add the CSS class shake, and then when you're not animating, have no class. Right? Okay. The next thing is we want in the code, this animating variable, we want to track what money you had previously. So on every re-render, we don't want to animate, but in here, we want to hook up special re-renders in this case. You probably don't need it, but what we want to do is, hey, if the dollars, again, we're using doubles, so using some precision number, since we're displaying 2 decimal places, we probably don't need to animate if anything less than that precision changes. However, we'll store that number, say it's animating, re-render, then after 500 milliseconds, so we'll animate for 500 milliseconds, we'll just remove the animating tag, right? Now I could just await and then do it here, but this is very simple. Okay, now let's keep going. So if I Alt-Tab and reload this, let's just check that .NET Watch. Okay, so a dirty change occurred. So if I press A, this is also a tip. You'll usually get dirty changes, but if you press A, it'll always do a full reload. So in the background, it can build while you're busy, Alt-tabbing and stuff. So, that's up again. If I click, hopefully if we look up here, it should wiggle. There we go. So now when we make money, we get some just, bounce around where we're like, woohoo, money's happening. Okay. So that's pretty cool. We've added some, animations and styling, and when I click a button, a number goes up and it slowly gets harder. But now I want it to get easier when it gets harder. So when the enemy health goes up, I want to be able to do more damage. So the natural thing to continue with there is in this shop, we did define that component to be able to do the upgrades, right? We have these upgrades, but we're not using them. So let's build a component that can upgrade these upgrades, right? So I'm going to call it the upgrade shop. In here, it already exists. Yes, I did create it, but it's empty. Now, in this case, again, I will just say render mode, interactive WebAssembly. I would get way better mileage off using global interactivity, but I do want to just nail home in the watch's heads that your app won't work because you probably forgot to specify the render mode, right? Again, this is inheriting from the game state. We need to get variables from the game state. Okay. Now, I should probably add to the global usings this. Oh yeah, it's the game state base. So actually, my usings helped me here. Okay. I'm going to paste in just some UI code. Oops, the hot reload happened in the background. So I'm actually going to stop that for now so it doesn't start up. Let's paste in just a little bit of code. So I'm just pasting in the UI here, and it is going to be a ordered list. And then for every upgrade in the upgrade enum, we'll get the current state, right? Then we'll have a list item with a button. And the button will be disabled if you can't afford the upgrade, right? So we'll define this method shortly, but using that upgrade state. When I click it, I want to purchase the upgrade using the current upgrade in the for each loop, right? The title, so the tooltip, this doesn't work on mobile, so it's probably better to use a tooltip that's mobile compatible, but we'll display a tooltip for that. And then we'll just show what is the upgrade and how much it costs, right? And then the current level. So let's define, first of all, whether you can afford the upgrade, right? So this is just pure C# code again, right? Taking in an upgrade state, whether you can afford it is using that game state from the base. If your current money is greater than or equal to the cost, right? Then, hey, you can probably afford that upgrade. The next thing is we want those tooltips for what the upgrades do. So we put comments in the enum, but here's exactly what the upgrades do, right? Increases the click damage by 1. We saw that in the formula. Each upgrade increases the damage by 1 because we don't multiply anything, we use the number of the upgrade level. Increases the damage by 1 per second. Click damage by 10%, so we saw multiplying the level of this by 0.1. And then the portal, so currently the passive damage, once we build it, will tick once per second, but we can decrease that interval using this fancy portal upgrade. Okay, but we'll get to these upgrade, especially the passive ones, right at the end. Okay, so let us now jump back. I'll run watch again. Okay, now we have some upgrades on the side, again, thanks to the styling I pasted in, but again, you can have some fun with how you do styling. Okay, so I'm going to quickly hold down enter the cheat, and then now, right, the game state's updating from this component, it's invoking a method, that click damage. Then when the, currency changes, the both of these components get notified, right? They both re-render. Now when I click the sword, the price goes up by a little bit, right? It's now level 1. Now hopefully when I click, woohoo, it's moving really quick, right? I can click and hold down enter quite a bit here, and then, slowly click it a bit more, the cost slowly goes up a little bit, and then we can start making more money more quickly, right? Okay, that's pretty cool, but now how do we make passive damage work, right? How do we tick this damage essentially every second? Well, again, I don't want the browser to override, so I'm just going to cancel the watch. What I can actually do is make a component here. It doesn't have any UI, but we'll just call it the passive damage worker. Okay. Now in this component, it's going to do a couple things. It's somewhat involved, but it's not too crazy. We want it to have access to the game state. We also want it to be disposable for reasons we'll show very shortly. We're just going to use a timer for this, and we'll call it just timer. We will make the tick. So we lied. We'll tell them it's 1 second, but people are impatient, so we'll secretly do it twice every second instead. Okay. We'll say an unlocked variable. So whether you've actually got passive damage yet, we'll just save some cycles if you don't actually need the passive damage. We mentioned that the portal decreases the actual delay between each ticks. So let's just track the current level. Okay. Which of the timers is this? It is, in this case, the system.threading. Now, let's get the current interval that it should be. So we know that like 500 milliseconds or 1 second, whatever we want to call the base, I'm just going to make it faster so that more things happen. The level of the portal decreases. So in this case, we want a less than 1 power so that it decreases. And in this case, the milliseconds will be that 500 times by, and then, 0.9 to the power of that level. So as you buy more portals, the delay will decrease. Now, if you buy enough levels, it will be less than 1. So we want to just clamp it to 1. Now, we could tell the user, or we'll just let them waste money. So I'll let them keep upgrading it below 1 millisecond. So it's their own fault for not doing math on the formula. Now, when this component is initialized, I want to register just some of these variables, but I also want to start the timer essentially. And we'll essentially start it stopped, right? Then we want to hook up a separate callback, so when the state changes, we're using this basically everywhere. And instead of re-rendering, in this case, we want to check if we should change the delay. So if they upgrade passive damage, then we'll go, hey, wait, maybe we want to actually start this timer. So let's build that. This function might be too big for Copilot to remember. I guess not. Right, so what does this do? Well, if the portal level changed, then we can just change the timer. Otherwise, if it's not unlocked, we say it is actually unlocked and then just start it. So we can either change the timer or unlock it, start it, and then change it. Okay. Now we mentioned what happens every interval. Well, some tick event happens. So let's say when you tick, we just call the game state, do the passive damage. And that's it, almost it. We do want to dispose the timer when this worker gets disposed, and call the base disposed, because remember, we're inheriting from this game state component. Okay. So that's a bunch of just effort, but remember, this is pure .NET, so if you know how to build desktop apps or web apps, and you've done some .NET, this should feel normal to build a game, which could feel scary to do. Now, the game state the passive damage worker, let us place that. Well, on the battle page, that's what we care about, right? When the enemy is on screen, we want to do passive damage. So we'll just place him here, and then that will just render, quote unquote, although it's headless, so there's nothing on the DOM. All of this is just to be able to run a timer. So let's hit start. We'll see if the build works just using the IDE this time. So it'll spin up, and then now if I speed run my way through here, where we just get a laser which does 1 passive damage. If I click that, we'll notice now my hands, they're up, but it's going through there, right? Every 500 milliseconds the number's going, I can click and it'll happen together, right? So that's pretty cool. We basically have a game here, right? I can quickly go through, I can make my sword do more damage, I can do, instead of 1 damage every 500 milliseconds, it can be 2 damage. I could now leave this open overnight and wake up to lots of passive income in game. Now we can buy other upgrades so that, as the example, it's hard to watch for the portal sample because it would decrease very slightly. But I promise this is slightly less than 500 milliseconds now, right? That is the crux of the game, right? We've shown a little bit of fun with CSS, some basic HTML, no component library, imagery, and just animations kind of take games a long way. That's why I kind of showed the cookie clicker example, where it's just a crazy web page with lots of stuff going on to just make it more engaging. And just the very simple things you can do with Blazor, building in a component-based way, right? We went through some pain just to show the new Blazor paradigm, but you get a lot of mileage out of the classic Blazor project where, you have one project and it's very simple, but I wanted to show it. So that's basically it for the demo segment. I'm going to switch back to the PowerPoint and let's continue. Now, if you want to play this game, I have the .NET 8 version. I didn't actually upgrade this site yet, but it's the same game. You can scan this QR code or go to game.lukeparker.dev. You can have a click around. I pulled it up. It is, if I go here, game.lukeparker.dev, it's the same game. You can buy things and have a play yourself if you're interested. Now the resources, well, the source code for this, you can steal it or modify it, use it as a reference. There's another sample I made, which some people might have asked about. I haven't checked the questions yet, but we did a very HTML focused game where it's just using styling and, it's a couple lines of CSS and it's just very webby, right? This is I'm going to use it very quickly because it is actually multiplayer. This is a networked, Blazor app where you can draw on a canvas and it's it's threaded to everyone, right? So if I draw on this screen, it draws for everyone else, right? But anyone can draw on this, so I'm not going to keep this up too quick because you give anyone a painting, you know what they're going to do. So that's a reference bit of code. It uses the canvas and drawing, and it's a little bit more in that regard. It's not using WebGL, it's just using the canvas. So you can use that as a way for networked, quote-unquote, gaming with Blazor. That's interesting. That Blazor game source code that I mentioned for other inspiration, like I mentioned, the link to that game. If you want the slides, you can take this QR code. The PowerPoint is on a GitHub just as a file. I've uploaded it there. But otherwise, thank you for watching. It's been a lot of fun. I really hope it inspired you to just have a play in your own time, build something, maybe make a game that you would want to play, or something that excites you. And with that, I'm going to look at the Discord and see what questions we've got. So, thank you everyone. I am looking at the questions in the chat now. So, the first question, how would you prevent game state from becoming God class? Well, you can, obviously, I injected one service, right? Game state in the program.cs here. We added a singleton game state. You could inject more than one thing, if you built backend web APIs, it's the same dependency injection. So you can build that in whatever pure way you'd like. In this case, it was simple enough where I'd rather just have one thing. Now remember, with the base class, you could inject more than one thing as well. Like you could inject, upgrade state and, enemy state here. And maybe if you have different actual pages, maybe, I don't know, you have a garden where you can grow things. Maybe you have different things around, right? So the answer to that is yes, you can do it however you'd like in that case. The next question, if you wanted to use some kind of 3D rendering with Blazor WASM, does that require interop with something like 3JS, or is there a more fitting WASM compatible API? To my knowledge, I am unsure if you can render with WASM, like straight to the screen, but what you can do is leverage the benefits you get with WASM. So say you're doing complex computations like physics and tracking many things on the screen and seeing what's visible, doing all of your sort of formulas that you invoke. That might be computation heavy. So that part is invoked in .NET. Then yes, to my knowledge, you have to actually interop with, whether it's the canvas or 3JS or WebGL, then you pass it to that. Now, other people might know the WASM specifics, but yeah, to my knowledge, just do the compute heavy stuff in .NET and WASM, and then you have to talk to the browser to get it on the screen. So the render eventually ends up on the UI. The next question. You might have already answered a similar question, but what do you think is missing from Blazor, if any, to be able to develop heavy 3D games? It's definitely not my area of expertise in terms of game development and heavy 3D games. One thing that could be nice is the multi-threading that might be coming in the next couple of .NET versions. At the moment, you are stuck with one thread, essentially, in WASM. You can get around it in some ways with, web workers or other weird ways to use it. But, there could be, like we mentioned, there is some interop you have to do, which is a bottleneck. But realistically, you can get a lot of mileage out there, so it's not a big worry for me. The next question, is this game easily cheatable? How could you change your in-game money from the browser? So in our sample app, it's in memory, which makes it at least a little bit hard to cheat. There are ways. There is .NET interop in JavaScript, and memory is memory, but that makes it hard. The easier answer is in the link I jumped to, so I'll pull it up. This one has a couple more features. It does persist between refreshes, which means it's super easy to cheat because you can just go into the application, the local storage, and then change some numbers in this JSON. So you could just say you have lots of money, right? It does have some fun anti-cheat because it updates every half a second. You have to type and edit and save that quickly, otherwise it resets with the next value. So there's a accidental anti-cheat measure, but the answer is it's quite easy. And ultimately, the game is for people to have fun, and there's no online leaderboard, so cheating is kind of, impacts only you, so you can do that. It would be interesting if people do build some packages that help you decompile or memory edit WASM apps in the browser. There's none that I know specifically, but I haven't looked too hard. So I'm very curious if, something out there is cool. Next question. Since you've been working with Blazor for a few years, how good is Blazor for production? So this is a good question. The main thing is you have to toss up you have to decide what is the purpose of your website, right? Is it trying to be your public facing sales funnel where the slightest delay will decrease revenue? I'm gonna completely butcher it, but like very simple things in the web are important. Like Amazon did the study where uh, I forget what the package is called, but essentially they started to preload a link when you had the mouse down instead of the mouse up event, so it's a few milliseconds faster, and that increased revenue by a number. I think it was only 1% or something very small. But performance and delay and things happening quickly is very important for those public facing sites where people are not necessarily a customer yet. So in those cases, you probably wouldn't want Blazor, at least in the old states. You could consider the static SSR these days with postbacks. That way it is just complete pure HTML and forms that post and then get new static HTML. I haven't explored that too much in production, so I can't vouch for that. But my usual answer is it's good for line of business apps, right? So you already have the client, it wants to do something complex. A customer waiting a few seconds for the WASM to download and load, especially if it's on a phone or something, and you're guaranteeing you're not losing their business, and then they're going to use the app for a long time, potentially to input a lot of data and do some complex things. In that case, it's quite good. But in those new paradigms, I can't really vouch for how well they do. So if you're using that new interactive auto mode, you can get HTML and then you get a SignalR connection thereafter that lets you actually click around, and then as the WASM loads in the background, whenever you change page next, it then goes to WASM. Like, that's a quite good story, although you still need a server and whatnot, so there's a lot of thoughts there, and there's a lot of reading you can do. But in general, yeah, my thinking is it's quite good in production. It's been in production for many years for clients across many different sectors, and there's been no weird errors in the case of .NET or Blazor's fault. The closest thing to the only warning I would give is the cache is quite unfortunate, and sometimes enterprise firewalls block .wasm files or the .dlls before they were that, but the WebCIL and the ability to there are workarounds. You can basically like X all the files to get around firewall scanning and stuff. So there are some gotchas for enterprise apps. However, it does work, and there are ways to fix it. So for a lot of the pains, you can get around it. The really nice story, obviously, is just it's one less skill to learn. Now, you will have to use JavaScript still. You're in the web, so it's not a you never have to use JavaScript thing. It's more of a you can do a lot of mileage by using component libraries like Blazor or Fluent UI for Blazor, and just build UIs quickly and kind of get things in the hands of clients quickly with mostly just .NET, right? So that's a bit of a tangent, but I hope that answered the question. Well, I kind of started answering the next question, which is how much web knowledge would someone need to build something with Blazor? Now, the answer is you can get a lot of mileage, right, with those component libraries. So an example being, let's say I go to Fluent UI Blazor, the demo site as an example. What you can do for most apps is every component library, they will usually just have a demo site. So Fluent UI and Blazor are the same. You find something you want to use, and then you just find the code and copy it. And that can get you a lot of mileage. You can kind of figure out how to do things, and then stay mostly within the land of .NET. Once you want to customize a little bit and do some really weird things, then you need a bit more web knowledge. But I mean, as a stepping stone to get more web knowledge, it is definitely a nice entry point where you don't like the friction to start is not there, where you can copy a lot from docs of component libraries, and that'll get your foot in the door. Where when you get to the point you need to do some weird stuff with JavaScript, you can interop a little bit. Again, docs are strong there, and just learn those bits as you need it. Yeah, someone said bad performance is perfect for internal tools. So yeah, Blazor apps, if you're, well, before you might use like WinForms or something, and then now it might be on the web. And honestly, Blazor server, if you're trying to build an app really quick, yes, you can query EF core inside your component, and it's server-side rendered, so it's not that big of a deal. But if you want to code it really quick, you can get something that works really quick. So there are a lot of bad things you can do, but that depends on the context and how you look at it, right? Next question. Are there any examples of production apps built with Blazor? I have some, but I can't link them, I don't think. I'm unsure about Microsoft Docs. We'd have to Google it. Um, yeah, I would Google it. There might be some case studies, but yeah, there's definitely quite a few in production. Most, I would say, are internal tools. Most would not be public facing for that exact reason. The closest thing to a sample from Microsoft was that shop they did for the .NET 8 demo, but that uses the new paradigms, which most code doesn't use. So, yeah. Are there any other questions? I'll scroll up a little bit. Someone already compiled them. Oops. Yeah, they in the .NET Conf. Yeah. Yeah, so you could look at the link there. Cool. If there are no more questions, I'll leave it for 30 seconds, but otherwise... Yeah. Cool. Yeah, I don't think there's any more questions, so thank you everyone for watching. I hope you had a good conference. It's been a lot of fun as a watcher and a presenter, so I hope to see everyone next year. But otherwise, I hope I inspired you. Have a play. Feel free to ping me in the Discord for any help with making fun things with Blazor. Thank you.